Assalamualaikum, a very good day everyone. My name is Umar Padilla bin Johan. My matrix number is J2080491. Today, the member of my group and I would like to present our bioproduct and bioreactor, which produce beer from barley malt and a cylindrically conical fermentation tank for beer that we have designed. Beginning with the introduction, beer is an alcoholic beverage produced by fermentation of grains, mainly barley malt, with hops and other components. Yeast perform the fermentation process by converting the malt carbohydrates into alcohol and carbon dioxide. The outcome is a tasty and refreshing beverage that has been enjoyed for ages because it contains the natural sugar necessary for the fermentation process. Barley malt is utilized as the major ingredient in beer production. The quality of the barley malt can have a significant impact on the flavor, color, and overall quality of the beer, which is a problem that can emerge when brewing using barley malt. To create the greatest possible beer, it is essential to utilize high quality barley malt that is free from impurities and has been stored properly. We believe that a variety of our own design can create high quality beer. In order to produce beer, barley must first undergo the malting process, which involves soaking it in water and allowing it to germinate, which actives enzyme that convert that starch in the barley into sugar. The barley is neck dried in a process known as kilning, traditionally using hot air. During this process, the enzyme alpha amylase and beta amylase are active. During the brewing process, this enzyme transforms the starch in the barley into fermentable sugar, which are then utilized by yeast to ferment into alcohol. The grits is combined with hot water in process known as mashing as the process advances to the next stage. During the malting process, enzyme transforms the starch in the grains into sugar, resulting in the production of worts, a sweet liquid. The wort is then boiled with hops, which impart bitterness and aroma to the beer before the boiling process begins. Hops are added to the worts in order to extract the alpha acid from the hops flowers, which impart bitterness to the beer. The heat of the boil isomerize or convert the alpha acid into a more suitable form, allowing them to dissolve in the wood. Hops are boiled to extract the essential oil and resin from the hops blossom, which add to the beer aroma and flavor. Because these chemicals are less soluble than alpha acid, they are often added later in the boiling process to preserve the scents. In addition, as some water evaporates during the boiling process, the sugar concentration in the woods increase, resulting in a stronger beer. The next step is fermentation, in which the wood is cooled and yeast is added to convert the carbohydrates into alcohol and carbon dioxide. Depending on the type of beer being produced, this process takes several days or to a few weeks. Saccharomyces cerevisiae is the yeast used, and wood will serve as the medium broth for the fermentation process.
For the important part in the bioreactor is the motto to stir or agitation the wort during the fermentation process. The agitation can help to ensure that the yeast is distributed evenly throughout the wort, which promotes efficient fermentation. It can help to keep the yeast in suspension, which prevent the yeast from settling to the bottom of the bioreactor and potentially slowing down or halting the fermentation process. The agitation speed between 50 to 150 rpm for the first 2 days of fermentation, and increase the speed between 200 to 300 rpm. For the type impeller is using its pitch blade turbine that consists of the central shaft with one or more blades that are set at an angle or pitches to create a swirling flow pattern in the liquid. The anchor agitator has a similar design, but the blades are perpendicular to the shaft, and it creates a more turbulence flow and better for mixing the heavier particles. Next, gas outlet or CO2 outlet is allowed to release the carbon dioxide that produced during fermentation. CO2 is a bioproduct of the yeast metabolized, and it's produced in large quantity during the fermentation process. If the CO2 is not released from the bioreactor, the pressure inside can build up, which can inhibit the growth of the yeast and slow down the fermentation. For the safety valve function, it's to release excess pressure that can build up during the fermentation process. This is important to prevent damage to the bioreactor and ensure the safety of the operator. Also, it helps to maintain optimal fermentation condition by preventing overpressure, which can negatively impact the yeast's ability to ferment. The malt and safety valve play a critical role in ensuring the proper function of the bioreactor and the quality of the final product. Function of CIP spray ball is provide an effective and efficient way to clean the reactor, and its associated piping chip spray ball are used to clean the reactor by spraying a clean solution in all directions, reaching all the surface and constant to remove the unwanted material. This allows to the removal of the bacteria, yeast and other microorganisms that can compromise the quality of the beer and the efficiency of the fermentation process. Next, pressure adjusting apparatus. During the fermentation process, yeast consume that the sugar present in the barley malt produce carbon dioxide and ethanol. The carbon dioxide can cause an increase in the pressure within the reactor, which can negatively impact the yeast's ability to ferment the malt. Pressure adjusting apparatus allow the operator to control the pressure within the reactor by releasing of the admin pressure as needed. It helps to maintain optimal fermentation condition, which is critical for the producing high quality beer. pH and DO probe are important in the bioreactor used for the producing beer from the barley malt because they provide a way to monitor and control the pH and oxygen level within the reactor during the fermentation process, and in the process is monitoring the pH level in the real time, allow the operator to adjust the pH as needed to maintain optimal fermentation condition.
CAD systems are used to control and monitor the fermentation process. They can control pH and DO levels, temperature, pressure, and other process parameters. This system can be used to manage and monitor the fermentation process in real time, which can be valuable for diagnosing and optimizing the process. Temperature is a crucial factor in the fermentation process since it impacts enzyme activity, yeast growth, and the production of byproducts. To keep the fermentation medium temperature within the optimal range for yeast growth and activity, this is typically between 15 and 20 degrees Celsius. Maintaining the ideal temperature range can increase the yeast efficiency, accelerate the fermentation process, and improve the final product's quality. It is essential to keep the temperature of the fermentation medium below the ambient temperature to avoid the possibility of thermal runaway. Thermal runaway is a phenomenon that occurs when temperature of the fermentation medium climbs uncontrollably as a result of the release of heat from exothermic processes occurring during fermentation. This can be detrimental to this and the end product's quality. PT100 sensors, platinum resistant electrode. A temperature control device typically consists of a thermometer or probe, a heating source, and cooling coils or jacket encircling the fermenter. Using a temperature probe, the temperature of culture brought in the fermenter is measured. A probe is one type of temperature sensor. Few temperature probes permit surface installation for temperature detection. Also, others must be put into or submerged in liquid in order to monitor the temperature. With the aid of a sight glass, the operator can see how the fermentation is going. The liquid level, color, and activity of the fermentation can all be observed through the sight glass, providing the operator with invaluable information about the bioreactor status. This can use this data to fine-tune your brewing process and turn out beer of the highest quality, whether that's by altering the temperature or adding more yeast. Yeast can convert the malt carbohydrate into alcohol without oxygen. Thus, an air input is crucial. A lack of oxygen during the brewing process can cause the fermentation to halt or turn anaerobic, which leave an unpleasant flavor and lower quality beer. The bioreactor's air inlet allows for measured input of oxygen to maintain optimum fermentation condition. The fermentation process can begin until yeast and other raw materials are added. Raw ingredients such as barley malt give the yeast with the nutrient and sugars it needs to ferment the malt and produce alcohol. Lacking sufficient yeast and other ingredients will prevent fermentation or result in an incomplete process, producing an unfree beer. In order to maintain ideal fermentation condition, the bioreactor has a yeast and raw material intake that allows for precise injection of this material. The device consists of a sensor and miniature tank containing an anti-foaming agent. A probe foam sensing and control device is introduced through the stop plate. When the foam rises and meets the probe surface tip, a current travels through the circuit, activating the pump and releasing anti-foam in a second. Before serving, the anti-foam must be filtered out of the finished product if it contains more than 10 ppm of active silicone.
If there is one step in the brewing process that gets overlooked, it's probably conditioning. Conditioning is how a beer is carbonated, and it can drastically affect the final outcome of the entire brewing process. Not only does carbonation contribute to a beer mouthfeel, but it also can mute flavors and help a beer develop new taste upon aging. When it comes to the brewing process, conditioning is the grand finale. In the beer brewing process, the beer filtration system is one of the indispensable processes for the production of high-quality beer, which plays an important role in the flavor, color, and sterility of the beer. The beer filtration process mainly includes incoming water filtration process, boiler water filtration process, centrifuge still water filtration process, trap filtration process, sterilization filtration process, compressed air vent gas filtration process, and steam filtration process. Beer packaging is an extremely important process in the production and sale of this beverage. We all know that beer can be packed inside bottles, cans, or kegs, each with its pros and cons. There is the reason to choose one or another kind of packaging among bottling, canning, or kegging. The bottling beverages can be performed into glass bottles or PET one. As far as beer packaging is concerned, it is uncommon to find PET bottles, as glass ones are always recommended for a long series of reasons. You will choose glass for bottle packaging if you want to communicate the high quality of your beer, as the glass is the traditional material from which beer bottles have always been made. Glass is hygienic, aesthetically pleasant, and neutral. It is a must if you own a microbrewery and you want to appear as an artisan who carries on a long tradition. Canning is a very common solution in beer packaging. Many big industries in the brewery field have chosen canning to pack their beers, sometimes paired with bottling as well. Cans do not bear the same traditional aura that comes with bottles, but on the other hand, They appear more innovative, smart, and easy. The perfect choice if you want to pack a beer aimed at a young target. Kegging is the less common process of beer packaging in B2C market, but it is the most employed when brewery want to sell its beer to another industry or business in considerably quantities. The reason are known and lie on the need to save space and time in packaging and transportation on high scale. In conclusion, using our designed bioreactor to produce beer allows for efficient mixing and aeration, which are important for the optimal growth of yeast and fermentation. From that bioreactor, with the use of barley malt as raw material and SC as yeast, we were able to control pH, temperature, and monitoring of the fermentation process up to the required level. By that, we were able to our beer product from the bioreactor we have designed.